Hello, everyone. Okay. If you can see me and hear me, just type one in the chat, please. Oh, lovely. Oh, wow. Okay. Excellent. Ah, that's a lot of people. Lovely. So good to see you all. We'll start in probably a minute just to get people to join. Thank you. Mhm. And okay, so welcome to the first webinar, first year 12 webinar for COMPOS'. My name is Vlad Chernov, and I will be doing most webinars. I'd say every other week, almost, not every week, but every other week, we'll have a webinar. And the webinars are designed to help you with the upcoming assignment. Okay, so I won't be going through past assignments. I will only be going talking about the future assignment. Year 12 has 10 assignments, and you have seen assignment 1, which is mechanics for physics, and it is mechanics for physics, and it is oh, I forgot the topic for maths. Never mind. And then, so I'll do at least one webinar for each topic, sometimes more than one. Okay. So I myself am a physicist, and well, I studied applied physics and maths, as well as computer science a little bit, but mostly physics. And I absolutely love physics, and I'd love to share my love for physics with you guys. And the first thing is to talk about why did we create COMPOS'? What is it for? What is what are we trying to achieve? Well, I like to say that if you want to be an athlete, for example, you don't decide to become an athlete when you're 18. You don't go to athletics university and say, "Oh, I'm going to be an athlete," or a footballer, or anything, or a musician. You don't decide to be a musician and then just take your music A levels and be done with it. You usually start when you're 10, maybe 11. So yeah, if you can cope with the assignment, it is not a requirement. It is not a requirement for COMPOS' that you do A levels or any particular course. As long as you can do the assignments, we're happy to take you. Okay. What team do I support? I don't know. I've been to a football match once, and it was England versus Bulgaria. Right, so that's so what am I trying to say? Yeah, so if you want to be an athlete, you don't go to athletics university, and you don't decide to become an athlete when you're 18. But somehow, if you want to become a physicist, that's what you do. You're studying your GCSE, Okay, you're 16 and you're going, okay, maybe physics is for me. Maybe I'll give it a go. So you do physics A level, and then, oh, I like physics. I go to physics university, and then I become a physicist. That's a bit too late. If you love physics, you want to start earlier. Okay, you want to start, I don't know, year 10, year 11. Okay, well, at least you need to start doing serious physics when you're in year 12, and that's what we're here for. We are, think of us like a athletic school, but where we train physicists rather than athletes. So it's an after-school activity. You come and you become good at physics, and it turns out to be true because 50% of our students went to Oxford and Cambridge. So we're pretty. I think we're doing a pretty good job here. Okay, we're not preparing you for Oxford or Cambridge. We're just teaching you how to physics. Okay, and turns out that people who've went through the rigorous training of COMPOS are accepted to top universities in the UK. Okay, so without any further ado, so yes, there's quite a lot of you in the chat. So I would ask just to restrict the chat for questions for me. Okay. And if you have a genuine question, just ask it in the chat. Sometimes I will be asking questions and I will ask for your response. Yeah. No worries. How do I join COMPOS? You do the first assignment, and if you do it well, we'll take you on. If you don't do it well, you can still participate. You can come to my webinars. This is called the follow along program. The follow along program, you have everything a normal student, COMPOS student has, except the small group tutorials. Because we don't have infinite money to pay our tutors. So we will have 400 students. We will select 400 students, and they will receive tutorials in small groups with students or with physics students. Most of you will be studying with Oxford students. Okay. But if you don't get in, you still have me. You still have the assignments. So hopefully that works well. And if you do the follow along program, you can still get the certificate, or a letter of completion at the end, a letter from Oxford confirming that you have completed COMPOS, even if you don't get in. So that's quite cool. Let's start. Yeah, it's a good line in your CV, although not all universities know COMPOS. It's only been 3 years, and not many universities know about us. But we're getting more and more popular, more and more popular each year. Okay. Right, so today's topic is mechanics, and I just wanted to show you this book. This is the book that I read when I was 13, and that's what started my love for physics. Okay, now if you want to do just maths, you can do the follow along. Although if you don't do the physics side of things, you won't get a certificate at the end, but you're welcome to stay just for maths. But if you join the main program, it is physics and maths. Sorry, yeah, let's start. You should be seeing my screen. If that doesn't happen, let me know. And you can use this link to view the whiteboard. Apologies, there's quite a few. We have only one for our year. Yes, just one assignment, the year 12. You will receive a link to submit your first assignment if you haven't already. Please check your spam folders. If you haven't received, you should have received it. Or if you registered today, you'll probably receive it in a few days. Okay, mechanics. Sorry, on the preferably if you submit it before the 10th, that would be great, because if you face some technical issues, we can sort it out before the 10th. So the first thing I'd like to remind you, because in physics we work with vectors a lot, and we need to know how to add vectors. So there are two ways of adding vectors. There's the parallelogram rule and there's the triangle rule. I will demonstrate both. So suppose you have two vectors, vector A and vector B. Okay, sorry, I'll redraw that. I don't like that at all. So you have vector A and you have vector B. And you want to add them. In order to add them using the parallelogram rule, you draw the first vector as close to the action vector as you can, and then you draw the second vector from the same point. And then you complete a parallelogram and the diagonal of this parallelogram is the sum of two vectors, A plus B. So you use the parallelogram rule, vectors drawn from the same point, vectors drawn from same point. You could also use the parallelogram rule for subtraction, and it's a bit that's not it. Can I copy? Yeah. No, that doesn't work. Okay. Okay. All right. So you draw the vector A, then you draw vector B, and this vector, would be vector B minus A. Right. Okay, the webinar is 90 minutes. Yes. Right. So you can use the subtraction using the parallelogram rule as well. So technically, this diagonal is A plus B. The other diagonal is B minus A. And if you do it the other way, it's A minus B. If you do this vector, it's A minus B. But okay. So the triangle rule. In the triangle rule, you draw the vectors one after the other. It's this tip to end method. So you draw vector A. This is the one that you're probably familiar with. And from the tip of vector A, you draw vector B. Vector B. And then the third side of the triangle is A plus B. And you can see that A plus B here and A plus B here looks very similar. Can you please leave the chat for just genuine questions? It is distracting me. Triangle rule. That's fine. The triangle rule for multiple vectors. If you have multiple vectors, you can draw them one after the other, and it's the same thing. So I won't get into too much detail here, but if you go A plus B, then C plus D plus E, and this vector would be vector A plus B plus C plus D plus E. You've probably done something like that in GCSE. If you've done GCSE, so yeah, that's the sum of the 5 vectors. Right. A 0 vector has 0 length, so just a point. A 0 vector. 0 vector is just a point. Now, some people say it has direction. It has all directions, and some people say it doesn't have any direction. Both groups are correct. It has all directions and no direction. So yeah, 0 vector. A unit vector is a vector of length 1. Vector of length 1. And interestingly, if you want to find a unit vector in a given direction, so vector A, modulus A is the length of a vector, is the modulus or length. If you divide vector A by the length of A, you get a unit vector. It would be a vector of length 1 in the direction of A. So unit vector in the direction of A. Yeah. So imagine that A has length 7. And if you divide A by 7, you get a unit vector. Is a unit vector example. Does that make sense? If you divide the vector by its length, you get a unit vector. Do you understand that? It's quite a cool result. What happens when there are 2 vectors? Well, you can have 2 different unit vectors because a vector is determined by the length and the direction. 2 vectors of the same length can have different direction. So you can have more than 1 unit vector. You can have a unit vector in this direction. You can have a unit vector in this direction, this direction. The language might be confusing, but because when we say unit vectors, we usually refer to the one unit vector along the x-axis. We usually call it I, the I vector, and the unit vector along the y-axis, which is the j vector. So these are the unit vectors. So I and j, they're special unit vectors along the x-axis and y-axis. A modulus vector is the absolute value. Absolute value is the modulus, is the length. Okay. Right, so this is just talking about vectors, just a quick refresher for those who've done it, and hopefully you've learned something new today. Cool. What is mechanics? What is mechanics in general? Well, mechanics is a study of different sorts of movements, right? So movement of planets, for example. Kepler was a really smart person that discovered Kepler's laws, and to do this, he assumed that the sun was at the center of the solar system, not the Earth. And when the book was actually published with the laws, it had a note saying that the readers of this book to a reader of this book, it might look like the sun is at the center of the universe, which is of course not true because the Earth is at the center of the universe. But if you want to do some mathematical calculations, it is very convenient to assume that the sun is at the center. So that's the story. You can read more about it. Okay. And somehow you have to do it all the time. Okay. Mechanics. What is the main problem of mechanics? The main purpose of mechanics, main problem of mechanics, is to determine the position of an object at any given moment in time. To determine the position, at any given time. And to do this, we use a radius vector. Radius vector RT. So the radius vector is a vector drawn from the origin to the position of the object. Recordings are published at the end of the day, so you will be able to view this recording today. So let's say an object is at position A, and this is the radius vector of point A. So RA is the radius vector of point A. If you know the coordinates of A, so example, A has coordinates 7, 12, then the vector RA is 7, 12. So the radius vector has the same coordinates as the point. Radius vector is a vector joining the origin, is the beginning, with any given point. And if this is point B, then of course it's a point. So let's say the object moves along this path. So at any given time, so at time t it is here. And this radius vector with respect to time. So radius vector with respect to time is the function returning the position at any given time. Okay. I know it might sound confusing, maybe not intuitive, but let's let's take a simple example. A bus is traveling at constant speed, 3 meters a second, starting and when t is 0, the radius vector is 7, 0. So what does that mean? So that means the bus is at point 70, 1, 2, 3, 4, 5, 6, 7, 7, 0. That's the position of the bus. And it is moving 3 meters a second. So after 1 second, the bus is going to be at 10, 0. After 2 seconds, the bus is going to be at 13, 0, etc. So we can write down the position of the bus as a function of time. So the position of the bus at any given moment in time is given by the starting position 7, 0 plus the speed, which is 3, 0, because it is 3 horizontally, 0 vertically, multiplied by time t. This is the position of the bus at any given time t. Okay, so let's substitute. When t is 1, where is the bus? R of 1 is t is a changing value, 10, 10 0, yes, 10 0. And R of 2 is going to be, you substitute 2, 7 plus 3 times 2 is 13, 0. 3, at 3 seconds, the bus is at 16, 0, etc. This is called the radius vector. The radius vector is a function, and if you substitute t, you get the position, which is quite cool. Let's look at this example. For example, fit projectile motion. Okay. So this is a projectile motion cannon. Let's make the speed and shoot. Okay. So if I take this position, so when t is 0.4, the range, so the x coordinate is 6 and the height is 4. So we can write that the r of radius vector when t is 0.4 is 6.13 and 4.36. Okay. Of course, if you're interested, you can calculate the RT. RT would be something like what's the initial velocity? I don't remember, but yeah. Okay. Then I hope that makes sense. Was it 20? Yeah, it was 20, and the angle was 40. Never mind. I don't want to get into this. Let's keep it that way. The point is, I'm just showing you that the radius vector is simply the position. And if you draw the vector like this. Okay. Kinematics versus dynamics. Well, that's an easy one. Kinematics studies how things move. Things move. And then dynamics studies why things move. Why things move. So in kinematics, we talk about the displacement, the velocity, the time. And in dynamics, we talk about the force, we talk about mass, we talk about acceleration. So, well, mass is not a vector. Radius vector, displacement. Displacement is the change in position. Okay, let's go here. Displacement. Displacement. So displacement is the change in the radius vector. So displacement S is the change in the radius vector, which is simply the radius vector final minus the radius vector initial. So let's say an object was at point A, and then the object was at point B. So the radius vector RA, and then the radius vector RB. And the displacement, the change in displacement vector is the change in the radius vector, which is, I ask again, please, can you not use the chat for anything else? Are there anything other than questions for me? It is distracting. Right. This vector AB, I never had this issue. Well, I think I never had this, so many people joining, but nevertheless. S is delta R. So it's the change in it's RB minus RA. It's the change. So this small vector is S, which is the equivalent to change in R. Right? It's RB minus RA. Okay, and velocity. Well, velocity is the change in the displacement over time. So the velocity V is S divided by delta T. It's displacement over time. So it's delta R divided by delta T. And it's RB minus RA divided, well, let's not do that. Just changing the radius vector over time. And acceleration is A, which is the change in velocity divided by change in time, which, yeah, well, that's about it. Okay, so this I have talked about mostly maths, mostly math today. Okay, there's a question: will I struggle with COMPOS if I just do maths A level? It depends. It depends if you can manage a whole new subject. You're welcome to give it a go. I mean, it is an intense course. Okay. Yes, I'm going to over the friction force, and this is here at the end. Okay. How to solve dynamics and static problems, free body diagrams. You need to know how to draw free body diagrams. When you draw free body diagrams, just draw a single object. Draw single object. Does it help with further maths A level? Of course it does. But I struggle with COMPOS if I do AQA physics. Well, I don't know. Draw. It doesn't matter which exam board you use. Draw a single object. Okay, so sorry, back to the question. Draw a single object and draw forces on that object. Okay, so mass and what are the forces? Well, there's the two strings, so tension 1, tension 2, and gravity, which is mg. Now let's add these three forces using the triangle rule. So we have T1 plus T2 and plus mg. Because the object is stationary, the total is a zero vector. So total resultant is a zero vector. If you differentiate acceleration, you get something called jerk. Is the rate at which acceleration changes. So yeah, it has a special name, but I haven't come across using it. Okay, this force, this mass, so we have mg and tension. That's easy. If you wanted to make a triangle out of it, it doesn't look like a triangle. It's T plus mg, and you end up with still having a single point. So resultant is a zero vector. Here you have two objects, so you have to do two free body diagrams. Free body diagram number 1, the mass m1. So you have T1, you have T2, you have mg, m1g, that's the gravity, that's the weight on this object. And there's another rope pulling here. This is T3. So 3 ropes. So when we look at this object, we are only looking, there are 3 ropes and the gravitational force. And you can draw the triangle here. So we have T1, we have T2, we have M1G, and we have T3. And you see that the total will be 0. Now we draw the bottom one, and the bottom is easy. That's M0G, and then there is T3. Okay. Third one, you have 3 objects here. You have to draw them separately. So you draw the mass M1. There's M1G pulling down. There's rope T. Because it's the same rope, the tension is going to be the same throughout the rope. So M0, this is M0G, and there's a tension force here. And then there's the pulley. The pulley, there's a tension force here, tension 1, let's call it. There's a tension force here and a tension force here. Okay, so when you have 3 objects, you draw 3 body diagrams. I will email the Miro links, yes, at some point. I don't promise to email it today, but I will do that. 4, find the magnitude and the direction of the force if the resultant is 0. Well, here you could approach it in 2 different ways. First, using a triangle. You know that the resultant is 0. So you have the 12 Newton force, you have the 15 Newton force, or you have the F force here, and you have the 15 Newton force, which is here. And this is 12, this is 15, and this is question mark. Because you can work out the angles, so this, for example, this angle is 50, this is 20, so this is going to be 30. 30. Oh, you can use the cosine rule. You can use cosine rule to find f, and then you find the angle as well. I'm not using Pythagoras here. 2, by resolving vectors. How do you do this by resolving vectors? Well, you resolve the vectors that are not along the axes, you resolve them into components. So f resolves into 2 components, f cos theta and f sine theta. This one resolves into 2 components. This is 15 sine 20, and this is 15 cos 20. This resolves into 2 vectors, which is 12 cos 40 and 12 sine 40. And then you can equate them. You can say that the horizontal forces balance out and the vertical forces balance out. So horizontal and 12 cos 40 equals 15 sine 20 plus f cos theta. 12 sine 40 plus f sine theta is 15 cos 20. And you can then express f cos theta is 12 cos 40 minus 15 sine 20, which is approximately, then you use your calculator, so 12 cos 40 minus 15 sine 20 it's 4. It's approximately 4.1 newtons, and f sine theta is 15 cos 20 minus 12 sine 40. Okay, sorry. I want to get so 15. Okay, 15 cos 20 minus 12 sine 40 6.38. Okay, newtons. Okay. Can you explain where 50 came from and how you started drawing cos? Okay. Let me step back here. And so you have we have this for the force. You want to resolve this vector into two components. And you draw two components. One component is horizontal, one component is vertical. We call it fx and fy. If you were to add fx and fy, that would give you f, as we have discovered using the parallelogram rule. Now, using trigonometry, you can work out that fx is f multiplied by cos theta. And that's what we do. That's why we label it, this vector, as f cos theta. Now, this one is going to be f sine theta. Now we take the second vector, let's say the 15 vector. We can resolve it into two components. Using trigonometry, we can work out that this long vector is 15 multiplied by cos 20. And the short vector is 15 sine 20. Does that make more sense? Okay, then thirdly, you can resolve this to these vectors. So this vector is going to be 12 cos 40, and this is 12 sine 40. Now the resultant, the total vector is 0. That's what it says in the question. If the resultant is 0, that means the horizontal vectors cancel each other out. And that means I can write that this vector minus this vector is 0, or this vector is these two. So 12 cos 40 equals 15 sine 20 plus f cos theta. And up 12 sine 40 plus f sine theta is 15 cos 20. Okay. And that means, so f cos theta, f sine theta, and you have, you can work out f. If you divide the second equation by the first one, so divide the second equation divided by the first one, you get f sine theta divided by f cos theta, and that is 6.38 divided by 4.1. F cancels, and sine over cos is tan. Tan theta is sine over cos. So theta is arctan of 6.38 divided by 4.1. Arctan is the same as tan inverse tan. The tan is 6.38 over 4.1, which is 57 degrees. 57 degrees. So theta is 57 degrees. Theta is 57 degrees. And f, to find f, you just substitute 57 degrees into one of them. So f sine 57 is 6.38. So f is 6.38 over sine 57. 6.38 divided by sine answer, which is 7.58 newtons. Okay, so this is the answer. Lovely. You got 30. 30. What is 30? I'm not following. Oh, 30, the angle. Well, if you think about this, so this is 50 degrees because this is 40, this is 50. So if you continue this line, this is going to be 20, and this means that this angle is 30 degrees. So this angle is 30 degrees. You could use Pythagoras, yeah, absolutely. Anyways, problem 5. I kind of want to talk about friction first. So let me talk about friction and then I'll come back to the rest of the questions. So friction is something new and it's something you don't really do even in A level. Okay. Some A level courses include friction, some don't, but friction is complicated-ish. Friction force. Plot a graph for the friction force versus the applied force. So that would look like this. So on the horizontal, we have the applied force. And here we have friction force. So here it is. So let's step back a little. Values and okay. So let's start pushing. When the applied force is 10, the friction force is 10. Okay. So if you push something with a force of 10 newtons, the friction force, if the object is not moving, the friction force is going to be 10. So let's draw that. 10, 10, 10, 10. If the applied force is 20, you can guess that the friction force is also 20. 30, 30. When the applied force is 40. Okay, so that's getting boring. 20, 20, 30, 30, 40, 40, 50, 50. If I push 90, 100, it has to change. 9, 10, 11, 12, 13, 14, 15, 18, 18, 19, 20, 3, 24, 5, 6. Ooh, something happened. Okay, up to 125, it was going like this. Up to 125, it was going like this. So the friction force 125. When it was 126, suddenly the friction force became 94. So the friction force dropped to 94. So the graph looks like this. Up, 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 down. And let's see what happens next. So if I increase the force, I'm increasing the applied force, but the friction force is not changing. So that's the graph of the friction force versus the applied force. So first, the friction force is exactly the same as the applied force. and then it is steady at 94. It is something to do with the coefficient of friction, indeed, yes. So what happens? Well, if the object is not moving, the friction force has to be equal to the applied force. Because otherwise, if the friction force is less, it would be moving right. And if the friction force is more, it would be moving left. But the object is stationary, they have to be the same. So friction works in the following way. This is called static friction. Static friction. Static friction is always exactly the same as the applied force. It has to be. If you think about it, there's no other way it can be. And then dynamic friction has a fixed value. And this fixed value of the dynamic friction is mu multiplied by the normal reaction force, mu r, where mu is the coefficient of friction and r is the normal reaction force. We can look at the mass. The box is 50 kilograms. The box is 50 kilograms. So the gravitational force is 500 newtons because it's a 50 kilogram box. So what's the normal reaction force on the box? Normal reaction force is 500 newtons. Well done. Yes, because it's not falling through the ground and it's not floating into the sky, so they have to be the same. And if the maximum friction is 94, can somebody work out mu? Force of friction is mu multiplied by the reaction force. Uh, 0.188. I think that is correct. Yes, it's indeed correct. So friction force is 94 equals mu multiplied by 500. So mu is 0.188. It doesn't have a unit. Okay. But this is the dynamic coefficient of friction because that's when it's moving. As you can see, it is static until 0.25. So there's mu static. This value is mu static multiplied by normal reaction. And this value is mu dynamic times normal reaction. So mu dynamic and mu static multiplied by normal reaction is the friction force, which is 125, which is mu static times R, and mu static is going to be 0.25. So we have two different coefficients of friction. And indeed, if you think about it, if you're trying to move a cupboard, it is very hard to start moving, but once it's already moving, it's easier. And that's why we say coefficient of static friction is greater than coefficient of dynamic friction, typically. Okay, but that's not important because in most cases, most problems assume the static coefficient of friction is the dynamic coefficient of friction. So bottom line is, so if object moving, sliding, the friction force is equal to mu r. If object stationary, the force of friction is less than or equal than mu r. Okay. Mu static and mu dynamic. So the maximum friction, the maximum value of friction is given by mu times r. You see this drop in the friction force. This drop in the friction force is due to the difference between mu static and mu dynamic. So this value is mu static times normal reaction, and this is mu dynamic times normal reaction. So they're different. Usually you would have a picture like this. You have bam and bam. So the friction force, this is the applied force. So while the object is not sliding, the two forces are exactly the same. Once it reaches the maximum value, which is mu r, not mu n, but normal reaction, mu r. Once it reaches the maximum force, then it levels off. Mu static is different. Mu static depends on the surface. It just typically mu static, for any two surfaces, you have mu static and mu dynamic. It's harder to get things moving than to continue moving. That's the point. I really didn't want to confuse you with two coefficients of friction because it's hard to understand one. So let's assume that the coefficient of friction is the same. So let's say, example, you have a box. The mass of the box is 20 kilograms. The coefficient of friction, mu, is 0.3. And you're pushing with a force of 20 newtons. What is the friction force? Well, first of all, you need to find the normal reaction force. So mg, that's going to be 200 newtons. And the normal reaction force is going to be 200 newtons as well. So force of friction maximum, the maximum value of friction is mu r, which is 0.3 times 200, which is 60 newtons. So the friction force can only be less than or equal to 60 newtons. So force of friction is less than or equal to 60 newtons. Now you're only pushing with 20 newtons. You're not exceeding the friction force. Therefore, the friction force is going to be 20. So if applied force is 20 newtons, the friction force is also 20 newtons. If the applied force is 40 newtons, the friction force is going to be 40 newtons. If the applied force is 60, it's going to be 60. But if the applied force is 70 newtons, the friction force is going to be 60 newtons. If the applied force is 80 newtons, it's still going to be 60 newtons. So that's what it means. Mu r is the maximum possible friction. Coefficient of friction is, well, it's the force of friction divided by normal reaction force. Coefficient of friction is the force of friction divided by normal reaction force. The maximum value of friction divided by normal reaction force. Because as you could see, the friction force changes. Okay. All right. Okay. Now, problem 8. Then. Okay. So let's say a car is decelerating. So the driver slams on the brakes. So how fast? Okay. How quickly can a car traveling at 20 meters per second stop? Mu and dynamic move quickly. Okay. Basically, if you have a box and you're pushing it along the ground and the box is moving, there's the normal reaction force on the box, normal reaction force, and the friction force is going to be mu multiplied by r, where mu is a coefficient of friction, and this is mg. So typically r is equal to mg, so the friction force is going to be mu mg. Okay. How quickly can a car traveling? So you need the friction, the coefficient of friction.
But
You
I
need
can't
to
unmute my mic.
I apologize for people who are being disrespectful. Okay. How quickly can a car traveling at 20 meters per second? So assume that the typical coefficient of friction between the tires and the road is 0.8. It sounds like it depends on a lot of things, but if you think about it, so let's say the driver slams on the brakes. So the car is traveling at 20 meters a second. So if there's a friction force, between the wheels and the road. And we know that the maximum value of the friction force is mu r. But this is mg of the car. This is the reaction force, r. And because the car is not going up or down, the reaction force is mg. So the maximum friction force is mu mg. So mu r is mu mg. And from Newton's second law, Newton's second law, force equals ma. And the force is mu mg. Mu mg is the force that is accelerating that or decelerating the car, is ma. M cancels, and acceleration, the maximum deceleration of the car is mu g, which is quite significant. Quite a significant result. The maximum deceleration of the car, maximum deceleration of the car is mu g. In this case, mu is 0.8, so it's approximately 8. So it's approximately 0.8 times 10, which is 8 meters per second squared. So we don't know what car it is. We don't know how heavy it is. We know nothing about the car. We only know one thing, is that the coefficient of friction, which is a typical value, right? So this is a normal value of the coefficient of friction. You know how fast a car can stop if you know the coefficient of friction. And if you know the acceleration, you can well say its acceleration is the change in velocity divided by change in time. So change in time is going to be change in velocity over acceleration, which is 20 over 8, which is 2.5 seconds. So a car can stop in 2.5 seconds. Right? And the same with acceleration, because the car accelerates because of the friction force. If you think about it, the friction force is pushing the car forward, and the friction force has a limiting value. So maximum acceleration of the car, maximum acceleration of a car is mu g as well. Maximum deceleration, maximum acceleration. So a car cannot accelerate faster than mu g. So whenever you read about cars and they say this car goes from 0 to 60 miles an hour in 0.8 seconds, no, it doesn't. Because you don't have enough grip. The coefficient of friction is your limiting factor. If you don't have friction, you don't have enough friction, the car won't accelerate, the wheels will spin. You can have all the power in the world fit into one car. You can but the power will just go into spinning the wheels rather than accelerating the car. Okay, hope that makes sense. We have about 10 more minutes left because I want to do some questions at the end. I'll just quickly go through these questions. I have done at least 3 or 4 webinars on this topic. They are on our YouTube channel. So if you go to YouTube and you go to our channel, COMPOS'24 Y12, you can watch my old webinars on the same topic. I go through harder questions. Today I'm taking easier questions. Okay. Wait. Oh, sorry, I don't have time for this one. Calculate the tension in the string joining the 2 masses. So we have 2 masses connected by a string, and we're pulling with 60 newtons. So what do we do here? We draw each mass separately. So draw the 10 kilogram mass separately and draw the forces acting on it. So there's mg, of course. There's mg. There's the normal reaction force, and there's the tension force. Then you write down the Newton's second law. Newton's second law is F equals ma. The resultant force is ma. But the resultant force, because R and mg cancel out, the resultant force is T. T is equal to ma. For the second mass, I have capital Mg. I have reaction 2, and I have F, which is 60 newtons, and I have tension to the left. So the resultant force is ma. Now, m capital, because that's the mass of this one, and m small is the mass of this one. So the resultant force is F minus T. So F minus T is mass times acceleration. Now I can substitute the values. I am looking for the tension. Well, in order to find tension, I first want to find the acceleration. So let's substitute what we know. So tension is 10a, and here 60 minus tension equals 30a. And now we just need to solve for t and a. So 60 minus 10a equals 30a, 60 equals 40a, a equals 1.5 meters per second squared. That's the acceleration. And the tension is 10 multiplied by a, which is 15 newtons. So this is how you solve a dynamics question. So you draw the two objects, you draw the forces, and then you write down Newton's second law. Okay. Is it 45? If the positions were, if the position was changed. Yes. Uh, the mic. Oh, the audio is good. Thank you.
Uh,
Just
excuse me.
yeah.
How did you get T equals 10A?
Okay. So I write down Newton's second law, which is the resultant force is mass times acceleration. But the only force which is unbalanced is T. So the resultant force is T. The resultant force is T. And M is 10. So that's how I get F resultant is ma, T is ma, which is T is 10a. Does that make sense?
Yeah.
Okay. Now, in this one, this is an interesting one because this is more like a question about Newton's third law, which is also important. So we look at each block separately. So let's look at the first block, M1. I'm going to ignore the vertical forces because they are balanced. There's a gravity and there's normal reaction. We don't care about that. So there's a force from the left, F. But then if you imagine you are block 1, you feel a force from the back, someone's pushing you, but also the block in front of you is pushing you right in the face. So there's a normal reaction force, let's call it R1, pushing you from this, because it's the contact force between the two blocks. It's the contact force between two blocks. It's a Jabra microphone. Right. Okay. And there is That's for the first block. For the second block, this is the 2 kilogram. For the 3 kilogram block, what you feel is the reaction force from the left, R1, and then there's the other one, R2. There's the other block pushing you from the right. And for the third block, there's only one force, which is R2. R2 is the reaction force. So these forces, these are the Newton's third law. Remember, R2 is action equals reaction. Yes, if one block is pushing the other block is pushing the first one. The third block is this. This is the 5 kilogram block. And then you can write Newton's second law. Newton's second law is Ma equals the resultant force. So Ma, which is 2 times A, equals the resultant force. Resultant force is F minus R1. For this block, 3A so Ma equals resultant force. So 3A, which is the mass times A, equals R1 minus R2. And for this block, Ma equals the resultant force. Oh, sorry, the resultant force, yes. So it's 5A equals R2. Brilliant. So, and now all you need to do is solve these 3 simultaneous equations. And yeah. Well, how to do this? You can add these, adding equation 1, equation 2, and equation 3. So equation 1 plus equation 2 plus equation 3. You get 2A plus 3A plus 5A equals F minus R1 plus R1 minus R2 plus R2. And that's cancel, 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 cancel. So 8, so that's 10A equals F, and F is 20 newtons, which is 20 newtons. So A is 2 meters per second squared. Acceleration is 2 meters per second squared. R2 is easy. R2 is 5 times A, which is 10 newtons. And R1 is going to be 2A, F minus 2A. F minus 2A, which is 20 minus 2 times 2, which is 16 newtons. So you found this. Sorry, I'm rushing a bit here. Please watch my previous webinars. The ones that you need, let's have a look. So playlists, year 12 so year 10 webinars, that's going to be useful. And you can watch, oh, no, that's the new year 10 webinars.
So I have a question.
Yeah, yeah.
For the previous question, the resultant force, is it always the same where F1 is minusing the left-hand side of R?
The resultant force is the total force. Because there are two forces, but they're in opposite direction, you have to just a second. You have to I'm trying my best, guys. I apologize. I think we need to get a moderator. for the next 2 sessions. Okay. Sorry, yes, so the normal the force okay. So mass acceleration equals the resultant force. That's Newton's second law. If you have more than one force, so for example, if you have F1, F2, and F3, you can say that the resultant force, well, depending on which way it is moving, if it's moving to the right, the resultant force is going to be F1 minus F2 minus F3. But if it's moving to the left, the resultant force would be F2 minus F3, sorry, plus F3 minus F1. So depending on which way it is moving. So that's how you do it. Hope that makes sense. Year 10 webinars, I recommend watching. Let me see. So there is equations, vectors, motion in 2D, motion assignments, solving equations, Newton's laws. So webinar 19. Webinar 19 from year 10. And from year 12, this is a playlists, year 12. And can't really see. Oh, should have given them better names. Center of mass. Center of mass assignments. Sequences in series, momentum. Ooh, somewhere early. Differentiation. Newton's laws part 2. So that's webinar 10 and 12 from year 12. All right. So that's that. Any questions? Right. We will be covering all COMPOS topics. So sorry, the chat is so quick. I'll answer the questions that I see. Yeah. Okay. And okay. Until this. Okay. Oh, that's good. That's great that I've clarified. I hat J hat. Unit I hat is a unit vector. Yes. Give me. Right. I hope this is. Okay.